Alright guys, so we're on our third lesson of the unit. Now we're going to be looking at dividing exponents, or looking at something we call the quotient rule. If you remember, quotient is kind of mathanese for telling us that we need to divide. To be able to understand this rule a little bit better, let's look at some of these expressions. First off, let's write them out in expanded form. So if we take this first one here, 3 to the 5th means we're going to have 3 times itself 5 times. So we could write that as 3 times 3 times 3 times 3 times 3. And then 3 to the 3rd means that we have 3 times itself 3 times. So 3 times 3 times 3. And now we can treat this as if it was a fraction because, frankly, it is a fraction. So if we remember for fractions, if we had the same thing on the top and the bottom, we could cancel that out and then it would just become a 1. So that would cancel. Those last 3's would cancel. We can cancel those 2, those ones. And remember, these don't go away. They just basically all became a 1. The same with those ones, they just became a 1. So this in essence becomes 3 times 3, and then that's just times 1, so it'll be itself all over 1, or which is the same as 3 times 3. And if we were to write that as an exponent, 3 times itself twice would be 3 to the 2nd. Okay, let's keep looking at some more examples with this. If we go to this next one, 2 squared on the top means we have 2 times 2, and that's being divided by 2 to the 3rd, which is 2 times 2 times 2. And again, we can cancel these out. So we got 1, 2 on the top, another 1 on the bottom, 1 on the top, 1 on the bottom. And so then, again, we're left with just a 1 on the top, and then this again becomes a 1, so we would have 1 on the top, and then 1 times 2, which is just 1/2. Okay, if we keep looking at this, 7 to the 3rd would be 7 times 7 times 7, all over 2 squared, which is 2 times 2. And now we couldn't cancel these because they're not the same number. So that actually we would just have to crunch and see what number we get in total. This could also work with variables. We could have x to the 5th, which is 5x's, all divided by x squared, which is 2x's. And we can again cancel, so we can cancel 1 here, 1 there, 1 here, 1 there. So we'd be left with 3x's on the top, all over 1, or we could just leave it there, and so we could write this as x to the 3rd. Okay, there's kind of a pattern going on. So like on this first one, we had a 5, a 3, we ended with a 2, here we had a 2, 3, ended with 1, 2 on the bottom, 5 and 2, ended with a 3. So in essence what we're doing is we're taking, if we have the same base, so again the same base, so here we have a 3 and a 3, so that works, so our base stayed the same. We just subtract our exponents, so we did 5 minus 3 gave us 2. Here we have the same base 2, so we know our end answer is going to have a base of 2. Then we have 2 minus 3, which is a negative 1. But remember, if we write that as without a negative exponent, we'd have a 1 on the top because that's technically our coefficient, all over 2 to the 1st, which is the same as 1/2. This one didn't work because we didn't, or this last one, this one didn't work because we didn't have the same base. Here for this x one it did, so we had the same base, so our base was going to be x. 5 minus 2 gave us 3. So this is working. Sorry. And so now we look at this one here. Let me circle it, sorry. So we got our coefficients, so we have a coefficients of 6 and 2. When we are dividing exponents, we still divide the coefficients. So 6 divided by 2 is going to be 3. And now we have our base of x, so that's going to stay the same. But our exponents are 3 and then 1, so this could be seen as 3x to the 3 minus 1. And 3 minus 1 is 2, so we'd have 3x squared. Okay, on this last one here, we have a base of y and a base of x, so they're not the same base, so we couldn't subtract those exponents. So that would honestly just stay there. And so what we just observed is something we call the quotient rule. And the quotient rule tells us when dividing expressions with the same base, we subtract the exponents. So basically we do top minus the bottom. So again, all of these up here, they had the same base except for these last two. Those ones didn't have the same base, so we couldn't use our rule, but these other four, they all had the same base, so we could use this rule. So when we divide expressions with the same base, we subtract the exponents. If we ever get confused with the rule, you can always just write it out and it'll give you the same answer. So again, x to the third, or 3 to the third would be 3 times 3 times 3 over 3 times 3, which is 3 squared. We cancel out 3, 3, 3, 3. Those all just become 1s. So this answer would be 3, technically to the first. But if we use our rule, we have a base of 3. So our base is going to stay the same and be 3. And so then we got to take our exponents, top minus the bottom. So it would be 3 to the third minus 2, which is 3 to the first, which again is 3. Let me move that, see if I can get it all the way in here. There we go. So that would be our final answer. And again, we could do the same thing with x's. So x to the fifth means we got 5 x's all over 3 x's. We have 3 on the bottom and more than 3 on the top, so we can cancel out the bottom ones and the top ones. So this just becomes x times x, which is x squared. Or if we use our rule, we have the same base of x, so our base is going to be x, and our top minus our bottom, 5 minus 3, means we get x squared. So again, this still works. Okay, so now let's do this just looking at our rule. So remember, if we have coefficients, so in number 3 here, 2 is our coefficient, and technically there's a 1 out front here, so we'd have to divide those still. So we divide coefficients, 2 divided by 1 is still 2. Now we have a base of x and x, so we're going to have x to the, there's technically a 1 on the top, so it would be 1 minus the 3. So this would become 2x to the negative 2. But we want to write this without any negative exponents. So 2 is our coefficient, so that would stay on top of our fraction. Now we got to take this x to the negative 2 and put it on the bottom. Except when we put it to the bottom, the exponent becomes positive. So this would be 2 over x squared. And again, guys, this would work if we just wrote it out. So if we had 2x, we'd have 2 times x all over x to the third, which is x times x So 3x's. We can cancel out 1 on the top and 1 on the bottom. So that gives us 2 over x times x. Oop, not a 2. Times x. Which gives us 2 over x squared, which is the same answer. All right. So here we got some more complex examples. Number 4, I'll leave to you guys to be able to do. If you want to check your answer will be 3x to the 7th. We'll at least look at 5 and 6 together, and then I'll leave you guys for 7 and 8. So 5 and 6, we're starting to combine rules. So here on the top, in the numerator, we have our multiplication. So remember back to last lesson, if we multiply same bases, what did we do to the exponents again? We added them. So this technically becomes, oop, that's a weird start of the x. So we'd have x to the 2nd plus 6th over x to the 3rd. So that would give us x to the 8th over x to the 3rd. And again, we got our same bases. So this would be x to the 8th minus 3, which gives us x to the 5th. And that'd be our answer, would be x to the 5th. And again, guys, we can always write this out. So if we have x squared, that means we got 2x's multiplied by 6x's. I'm going to cross my lines. I'm going to probably drive some of you guys crazy. And then we have all divided by 3x's. So we can still cancel out the top and the bottom. So we got 1 on the bottom, 1 on the top, 1 on the top, 1 on the bottom. So those all become 1s. So we're just left with x times itself 5 times, which again gives us x to the 5th. That still works. Okay, in 6, we have coefficients, so we got to divide coefficients, so we got to do 3 divided by 6. That doesn't divide nicely, so we have to simplify this. So this would simplify down to 1 over 2, so we'd still have a 1 on the top, then a 2 on the bottom. Now we got to simplify these, so x squared times x to the 4th. We add those exponents, so it would be x to the 2nd plus 4. And we do the same thing on the bottom. So it would be x to the 2nd plus 5. And so that comes down to being 1, or we can not even write that, we could just write it as x to the 6th all over 2x to the 7th. We could always write it out, but we're just going to use our rule. So again, our base is x. So when we do the subtraction, we bring our base to the top. So we're going to have x to the 6th minus 7. And our coefficient stays on the bottom, so it would be 2. So this would become x to the negative 1st all over 2. And we got to write this as a positive exponent, so maybe we will write the 1 just to help us see what's going on there. So the 1's going to stay on the top. We move the x to the negative 1st to the bottom. So this becomes 1 over 2x. Okay? I'll leave you guys 7 and 8 just so you have what the answers are on those. So you should end up with 1 over x squared. And then on number 8, you should end up with 2x. Okay. Now we're going to look at some area problems. So remember in last lesson we looked at finding the area of rectangles. And remember the area of a rectangle is found by the length times width. And that equals our area. Or guys, just we need to multiply the two sides. So here we're given, let's say this one's length, and we're wanting to find the width. So what we'd have to do, divide both sides by the length. So to get the width, it'd be equal to the area divided by our length. And we have our area right here, which is x to the third, y to the seventh. And we're dividing that by our length, which is x squared, y to the fourth. And now we're going to use the same rule that we've been looking at, but now we're going to have two different bases. We're going to have x, and then we're going to have y. So we're going to have this is equal to x to the third minus 2, because we subtract the exponents, times y to the seventh minus 4. So we'd get x to the first technically, but we can just write x, y to the third. That would be our answer. And we do the same thing for number 10. Be width is equal to the area divided by the length. So we'd have 30 x to the 10th divided by 6 x to the 8th. 30 divided by 6 is 5, x to the 10th. So we'd have x to the 10 minus 8, which is equal to 5x squared. Okay? Alrighty, so there's our lesson for 7.3, the quotient rule. Remember to give these examples, give 4 and then 7 and 8 a try on your own. As always, if you have any questions, please let me know.